Hello, beautiful, lovely students. Happy to have you back. We're going to be doing lesson 6 now, which is solving simple linear equations. I call them simple only because they're not going to have too many things we have to simplify in them. Okay, in the next lesson, we're going to beef these things up and just add some more distractions, more craziness going on. That way we have to simplify it first. But in this one, not too much to simplify. The last couple problems a little bit, but still not too bad. Okay, so in this lesson, we're going to verify what a solution to an equation is. We're going to check if the solution we're given actually is a solution. We're going to learn what that means. We're going to solve equations using the subtraction and addition properties of equality. We're going to be able to translate sentences into equations to solve. So that's that kind of real life application. And then we're going to do the same thing with the division and multiplication properties of equality. And again, translate some problems. And then we'll solve some that require actual simplification first. So the application we're trying to build up to, you want to start getting in shape, good for you. So you decide to do 100 push-ups per day. I'd say that's a lot. I think 30 per day, if you can do that consistently every single day, totally plenty. But look at you, you're a go-getter, 100 per day. So this morning you did 3x push-ups, and tonight you'll do the rest. How many push-ups do you have to do tonight if x equals 25? So that means that you did essentially 3x would be 3 sets, let's say, of 25. So you did 25 3 times. And if you want to do 100 total, well, we're going to be able to find out, hey, what is left over at the end? So we're going to be able to set that up as an equation. But for right now, we're going to move on from it. We'll come back later. So a little bit of a warm-up. Just going to practice evaluating a couple things here. Okay, I really encourage you, by the way, whenever something is labeled warm-up, try it on your own. Usually if I label it as warm-up, it means you should already have the skills to do it. All right, so we're going to evaluate the following for specified value. X plus 4 when x is 3. What we're going to do is take the x, we're going to replace it with a 3, add the 4 to it. This is going to give us 7. Notice I put the 3 in parentheses. It might seem unnecessary, but I promise at some point those parentheses are going to save you from making a mistake, so please do it every time. Next one, number 2, we have negative x squared plus 7, and x is negative 2. So I'm going to write negative. Where I see the x, I'm going to write parentheses, square it, plus 7, and then I'm going to take that negative 2, and I'm going to put it inside of those parentheses. Notice here those parentheses make a big difference. Negative 2 squared is positive 4. Okay, so if I simplify just that negative 2 to the power 2, that's that positive 4. Then I still have a negative sign in front and a plus 7. And now negative 4 plus 7, if I instead do 7 minus 4 in my head, that's going to be 3. And it's positive because 7 was the bigger number there. Please always remember when we're adding together a positive with a negative, always do big number minus small number, and then just check if the answer should be positive or negative. Okay, number 3, we have x, so I'm going to write some parentheses, and then, parentheses already in the problem, x cubed, more parentheses to the power 3, plus 4y, so 4 in parentheses. If that looks messy, you are more than welcome to write this in whatever way makes most sense to you. But what I like to do is write wherever I see a variable, I like to put a set of parentheses empty. Okay, so where I see the y, another set of parentheses here. And then once I know what that variable is, then I just write it inside of those parentheses. That way I already have a placeholder spot, and then I just got to plug it in. So where there was x's, I'm going to write negative 1s. And where there was y's, there's just one of them, I'm going to write a 3. Okay, so those parentheses are just placeholders. That way I know where to put my variables. Now I start simplifying here. Okay, first things first, we have parentheses, and inside of there I have an exponent. So right here, negative 1 cubed is negative 1, because 3 negative 1s. So now I have a negative 1 in front. I have negative 1 plus 4 times 3. Because I already did that negative 1 cubed, I can go ahead and do this 4 times 3 now, which is 12. Okay, so now inside of those parentheses, I have negative 1 plus 12. That is positive 11. Okay, so now I have negative 1. And again, negative 1 plus 12 is going to give me positive 11. Negative 1 times 11 is just negative 11. All right, so then we're done with that one. Now we have x minus 2y plus 5z squared. So we have a value for each variable. Where I see each variable, I'm just going to go ahead and make a set of parentheses. So for the x, I'm going to make some blue parentheses. Where I see negative 2y, I'm going to do negative 2 with some parentheses, and then plus 5z squared. So a 5, some parentheses, and squared. And now I will just plug in each of those values. So where I had an x, I'm going to write a 1. Where I had a y, I'm going to write a 7. And where I had a z, I'm going to write a 4. I simplify this by first doing the exponent. Okay, so 4 squared in the back there is going to be 16. Okay, I can go ahead and write the rest of the problem around it. I have 1 minus 2 times 7 plus 5 times that 16 I just got. 2 sets of multiplication here. Okay, so I can do each of them. I have 2 times 7 here in the middle. So this is going to give me negative 14 there. And then I have 5 times 16. Okay, 5 times 16 is 80. I'm going to have a plus 80. When I add this all up, I have 80 and 1 are both positive. Together, those make 81. And then I have a negative 14. Okay, so what I'm really doing here, I'll do it on the side, is I'm doing 81 minus 14, trying to figure out what that is. So I can go ahead and subtract the 4 to get 77, and then subtract the 10 to get 67. So all in all, 67 there for number 4. All right, now we're going to actually solve equations. So we have learned how to simplify using Please Excuse My Dear Aunt Sally or PEMDAS. That's what we were just doing. But now we're going to solve equations, which is essentially the opposite. Okay, so a solution to an equation is a value of a variable that makes a true statement when substituted into the equation. So a solution is going to look like, down here, x equals negative 5. Okay, where you have x, a variable, equals a number. Every solution we get will look like a variable equals something. So now when a problem says solve, it is shorthand notation for solve for the variable, which means to isolate the variable on one side of the equal sign. So we have right here, again, x equals something. Now, to solve, we're going to perform the order of operations in reverse. So instead of PEMDAS, you turn it around very conveniently, it says SADMEP. So we are going to follow SADMEP, which means subtract, add, divide, multiply, exponent, parentheses. Everything is just reversed. Okay, but we really only have addition, subtraction in today's lesson. But we're actually not going to actually solve quite yet. We're just going to verify that a solution is in fact a solution. So what we're going to do, we're going to plug in to number 5 here, x equals 5 into this equation. That gives us 3 times 5 minus 2 equals 13. And we're just going to see if this is true. Okay, 3 times 5 is 15. 15 minus 2 is in fact 13. So we have 13 equals 13. Okay, I'm going to put a little check mark here. Didn't need these equal signs on the left, by the way. Sorry about that. But since we get a true statement here, I'm going to say true. So x equals 5 is a solution. Okay, what that means is that x equals 5 just made this equation true. Okay, this is how you check your work. Okay, when we solve all these equations, you will do this process we just did. You will plug your number in to make sure you got the answer correct. All right, let's try another one. We have 4x minus 2 equals 2x plus 3, where x is 3 over 2. So I'm going to substitute in 3 over 2. So 4 times 3 over 2 minus 2 is supposed to be equal to 2 times 3 over 2 plus 3. Let's see what happens. 4 times 3 over 2 is going to be 12 over 2, which is 6. Okay, so we have 6 minus 2 equals, over here, 2 times 3 over 2. Those 2's are going to cancel to just give us 3 plus 3. So 6 minus 2, that is 4. And on the right side, 3 plus 3 is 6. That is not true. I'm going to put a big red X. Okay, and I'm going to say false. Okay, and when something is false, that means x equals 3 over 2 is not a solution. Okay, so if you solve an equation and you get an answer, you plug it back in, If you get a true statement, good, that means you got it right. If you get a false statement, that means you messed up somewhere and your answer is not actually the answer. You should try it again. All right, now we're gonna learn how to actually solve. So first, addition and subtraction properties of equality. Okay, if you have an equation, like let's say A equals B, so for example, 3 is equal to 3, that's a true statement. If I add the same number to both sides, so if I say plus C on both sides, for example, let's say instead of 3 equals 3, I have 3 plus 1 equals 3 plus 1. Well, that now says 4 equals 4. Hey, still true. Okay, so what we just saw is that if you add the same thing to both sides of the equal sign, you actually didn't change anything. You just made it look a little bit different. Okay, so this holds the equality. This keeps the statement true, and the same thing is true for subtraction. Okay, 3 minus 1 is equal to 3 minus 1, where here 2 is equal to 2. If I subtract the same thing from both sides, we are going to get an equivalent answer. Okay, sorry about my throat, a little dry. All right, and sorry if you can hear my dog barking. Hopefully it's not too loud. Okay, so we're going to solve x minus 24 is equal to negative 33. So remember, SAD MEP, okay? Have that back in the back of your head. SAD MEP, where what we want to do is get x all by itself. So right here, our goal is to get this x alone. So just think, if you want to be a loner, you're going to get rid of everyone that's next to you. You're going to get away from people. So what we're trying to do is send this 24, this negative 24 to the other side. Okay, we just want to get rid of it, move it out of there. So the way you do that is whatever operation you see, you're going to do the inverse of that. So since it says minus 24, I'm going to do plus 24, because again, right there, you can see that plus is the opposite of negative. Okay, these are inverses. And I'm just trying to do the opposite because I want on this left side, when I add together negative 24 and 24, I want to get a 0 here. That way, this now says x plus 0, but hey, I don't have to write that 0. Okay, these 24s are just going to cancel out and go away. Okay, but now, rule of equality, I just did that on the left. I have to do the exact same thing on the right side. So see how I do the same thing, plus 24 on the right. I have my equal sign drop straight down, and now negative 33 plus 24, this is going to be equal to negative 9. So I get that x equals negative 9, and if I want to check if this is actually a solution, I can plug it in. I can do negative 9 minus 24 equals negative 33, check if this is true, which it is, and so that verifies that I did in fact do it correctly. Okay, so my solution here would just be x equals negative 9. Okay, so now, number 8, I'm going to show you a little trick for staying organized, okay? Now that we know what we're actually doing, when you do these, I recommend you draw a vertical line through the equal sign, just like this. That way, you have to do the same thing on both sides of that red line, and it reminds you where your equal sign is the whole time. So what I'm going to do is, it says x plus 14. I want to get x all by itself. I want to make x a loner. So I'm going to do the opposite of plus 14, which is minus 14. And I'm going to do that exact same thing on the right side of the equal sign as well. Then when I simplify this, 14 and negative 14 cancel. Okay, they're inverses. That's the whole point, is to get rid of them. The x is still there. The equal sign is where the red line is. And then 1 minus 14 is negative 13. Okay, so my solution here, I can now write it below, nice and clean. X equals negative 13. If I plug negative 13 in for x, I'll get negative 13 plus 14 equals 1, which again is a true statement, so I know I did it correctly. So I always encourage you on all of your tests and all of your homeworks to check. Is negative 13 plus 14 equal to 1? Add them together, and hey, look at that. It is, which means we did it right. Okay, so you're going to notice I draw that red line and all these other little neat little pieces of work to make sure I stay organized the whole time. I recommend you do the same. Okay, so let's practice. I encourage you to pause the video and try. These ones involve fractions. Let's see what we got. First thing I'm going to do, vertical line through the equal sign. Okay, then I'm going to look where x is. We have x right here. I want to get x all by itself. So I'm going to do the opposite of what's happening to x. X is minus 7 over 10, so I'm going to add 7 over 10. And I'm going to do it to both sides. Okay, because I need to do the same thing on both sides. On the left, these are going to cancel because they are inverses. X just comes down. Nothing happened to x. The red line is the equal sign. And 5 over 10 plus 7 over 10, common denominators. So all I do is add 5 and 7. I get 12 over 10. And then now I can just simplify this, okay? I'm going to move the x a little closer to make it look nicer. And 12 over 10, top and bottom are both divisible by 2. That's 6 over 5. So my answer, x equals 6 over 5, is the solution. Okay, again, that organization is key. And if you want to check if you got it right, plug 6 over 5 back in. See what happens. Bet you it's going to work. Okay, number 10. Vertical line through the equal sign. Whatever's happening to x, I do the opposite. So it's plus 5 over 4. I'm going to do minus 5 over 4. Okay, again, just doing the inverse operation there. I do the same thing on both sides. When I simplify, this one's a little bit harder. On the left side, no big deal. These are inverses, so they cancel. And I have x equals, but now this part, not quite so clean, okay, because I have no common denominator, right? 5 over 6 and negative 5 over 4. I don't exactly know how to put those together immediately. So what I'm going to do is I'm going to do a little scratch work down here on the side. 5 over 6 minus 5 over 4. Okay. I need a common denominator. The LCM, least common multiple of 6 and 4, is 12. So I'm going to have to multiply top and bottom of the first fraction by 2 and top and bottom of the second fraction by 3. This is going to give me 10 over 12 minus 15 over 12, which is negative 5 over 12. And now that I have those two fractions put together, I just bring that answer back up here to the top. Negative 5 over 12, and that is my solution. Okay, and again, if you want to check, plug it back in. Make sure that you verify all of your answers. Okay, now we're going to require a little bit of simplification first. Not too much simplification, though. So solve equations that require simplification. It is often easier to solve for a variable by simplifying one or both sides of the equation before applying the addition and subtraction properties of equality, meaning we want to make it look as simple as possible before we start doing the work. So over here on number 11, notice the left side of this equation could be simpler. Okay, so what I'm going to do is start the same way. I'm going to draw this vertical line just to keep me organized. But then I'm going to combine like terms before I do anything else, okay? Always try to simplify before you try to solve. So what I mean by that, we have a 9p and a negative 8p. Together, that just makes 1p. Okay, so I'm going to have p, that plus 7 is still there, and then negative 7 on the other side. Now this equation is nice and easy to solve. Okay, I have a plus 7 attached to that p, so I'm going to subtract 7 from both sides. When I do that, these 7s on the left cancel because they are inverses of each other. And I drop down this letter p. Negative 7 minus 7 is negative 14. And so p equals negative 14 is my solution. But again, notice how much easier that problem became just by combining like terms before trying to solve. Okay, number 12. Same thing, just a little bit more to do here. So I'm still going to start by drawing my vertical red line. But this time I have to do the distributive property. This negative sign needs to get distributed before I can really do anything else. So the 11c I'm going to leave alone. Then I'm going to have that negative sign distributes to give me negative 10c plus 12. Because negative and a negative on that 12 make a positive. I still have a plus 5 there. And then a negative 8 on the other side. When I combine like terms, 11c and negative 10c give me 1c. 12 plus 5 gives me 17. And again, negative 8 on the other side. I'm going to clean up that 17 real quick. All right, and then now I want to get c by itself, so I'm going to do the opposite of what's happening to c. It's plus 17, so I'm going to subtract 17 from both sides. Okay, subtraction property of equality here is going to allow me to cancel out those 17s. And I drop down my c. On the right side, -8 minus 17 gives me -25. And I can go ahead and say, bing, bam, boom, c is equal to that -25. And done. Number 12 is solved. Okay, a little bit more practice. We're making it a little bit harder, then we'll do some applications. Okay, all we got to do is make sure that we distribute and combine like terms before we start rearranging anything. This time we're going to have to rearrange a little bit more, though, than just one step. So first, vertical line. Keep us organized. Now, we look on each side. We have some distribution we can do. So we're going to go ahead and distribute. That way we can simplify this left side. 4x minus 24 is what we get, because 4 times x, 4 times -6. Then we still have a plus 15. On the other side, a -17 plus 3x. Now we can combine like terms. On the left, -24 and 15 is going to combine. -24 plus 15 is -9. And that right side is going to stay exactly the same. All right, now we got to think. We have 4x minus 9 on the left, -17 plus 3x on the left, on the right, I should say. We need to get all of the x's together. Okay, so the key here is we need to get x's together. Okay, we want all the x's in one spot. So I need to move that 3x to the other side. All right, there's only one way to get it there, though. I have to cancel it out from one side and then do that same thing on the other side to keep things equal. So in order to move this 3x over to here, I can't literally just move it. So the way we do it is we subtract it from this side. Okay, that way on the right, they cancel. And on the left, I'm going to subtract it from the 4x. Notice where I wrote that down, though. Okay, over here on the left, I wrote 4x minus 3x in a nice little stack right here. Okay, look at that stack. That way I know exactly where those x's are going. I want to stay as organized as possible so I don't add together the wrong things. So on the left side, 4x minus 3x, that just gives me x. And then notice that these other things were unused. So I'm just going to drop them down. Okay, -9 drops down, -17 drops down. I didn't do anything with them yet, so they're still just there. Okay, so now we have a problem that looks just like the ones we were solving earlier. We have x minus 9 on the left. We have -17 on the right. So we're going to go ahead and add 9 to both sides. And that is going to leave us with just x on the left because these 9s are going to cancel. Okay, goodbye 9s. And on the right side, -17 plus 9 is going to give us -8. And so we are done. We have x equals -8 is our solution. So key steps there. Simplify as much as you can. And then when you get to this middle step here, where you have x's on both sides, our number one goal is to get the x's together. Okay, we want all of our x's in one place. That way we just have one variable. Okay, when the variables are spread out, we don't have it isolated. We don't have it the same. Okay, so we want to get it all on one side. All right, let's try again. Now we got even more simplification to do. So we're going to break it down. On the left side, we need to distribute a -2 to a set of parentheses. We're going to get -4x plus 2, and we still have a -12 there. On the right side, the -17 stays the same, but then we're going to distribute a 3 to a -x and a 2. Okay, that's going to give us -3x plus 6. On each side, we're going to combine like terms. So on the left, -4x doesn't have anything to combine with, but 2 minus 12 is -10. And on the right side, we have a -3x that has no friends, so it just stays -3x. But -17 and 6 are going to give us a -11. Okay, so now remember, our goal is to get x's together. We want all the x's in one spot. Okay, this is very different than real life, if you know what I mean. All right, so I'm going to try to get all the x's together. I prefer personally to always move the x's to the left. However, you can move them to whatever side you want. So in this case, I am going to move these 4x's to the right. Okay, and when I say move them, I mean to cancel them out on the left and put them over on the right side. Okay, but that's how you move something to the other side, is you cancel it from one side and then do that same operation on the other side. Okay, the reason I'm doing this is mostly just to show you that it's an option. You can put the x's on either side, and as long as you do it correctly, the equation still holds. Okay, but now, note on organization. Notice, x's over x's here, x's over x's here. The other numbers, I'm just going to drop down, and so I make sure not to write anything under them. That way I don't get confused with what I'm writing. Okay, so now I can see that I'm going to have 4x and 4x cancel. I drop that negative 10 down. And on the other side, negative 3x plus 4x is 1x. And that negative 11 drops down. Now all I have to do is move that negative 11 to the other side by adding 11 to both sides. All right, that's going to cause the 11s to cancel on the right. And it's going to leave me with 1 is equal to x. And it's okay that that x is on the right. A perfectly valid solution. We're all done with that one. Okay, a lot more steps in that one. And that's going to kind of be the theme moving forward. We're just going to make them a little bit harder, couple more steps each time. Okay, quick little applications, and then we'll be done with this video. So when solving application problems involving algebra, it's important and also helpful if you're able to sketch a diagram. That'll usually make life easier. If you can say what the variable represents, that is necessary, not just helpful, but you always need to know what your variable is representing. Okay, and so state what you know, state what you're looking for, and whatever you are looking for here, this is the key thing. What you are looking for, that is going to be the variable you define. So when we label something as x or y or z or whatever letter we choose, we're labeling the thing we're looking for, and that is also our variable. So what we're going to do, we're going to try to draw a picture. We're going to try to find out what we need to find out, like what are we searching for. We're going to call that thing a variable, and then we're going to be able to solve and see what we get. So first problem here, Julie rode her bike a total of 23 miles from home to a friend's house and then to the beach. The distance from Julie's house to the friend's house is 12 miles. How far does the friend live from the beach? So now notice this last question. How far does the friend live from the beach? Okay, that tells us what we're looking for. Okay, we are looking for this distance. So what we're trying to do is we are trying to find out how far this friend lives from the beach. So as we draw our picture, that is what we're going to label with our variable. So we're going to go ahead and make a little sketch. Okay, Julie is riding her bike home to friend's house and then to the beach. So we're going to start at home. I always forget the right way to do this. I think it's up, right, over, rooftop, this way. Hey, first try. Look at that. Okay, house without picking up your pencil. All right, we're going to go from the house to a friend's house. Now I know how to do it. Can do this next one faster. All right, and then from the friend's house, we're going to the beach. So for the beach, I'll just draw some waves. All right, and what we know is that the total distance from her house to the beach, Julie's house to the beach, is 23 miles. But what we don't know is how far it is from the friend's house to the beach. But hey, look at that. It tells us the distance from Julie's house to the friend's house is 12 miles. So we can plug that into our picture right here. Okay, 12 miles from house to house. And then we don't know the missing distance, so we're going to go ahead and call that one x miles. Okay, so what we are solving for is this x miles right here in the middle. So now we're going to set up an equation that represents this situation. Whenever you have a total, that's going to mean to add up the individual parts. So the equation we can set up is going to be the summation, or the addition of the individual parts. which is going to be the 12 miles we know plus the X miles that we don't know. And this is going to be equal to the total distance, which is 23. Okay, so we have the two individual pieces add up to the total distance. We can now just go ahead and subtract 12 from both sides. Notice I'm going to draw this vertical red line just like I was doing before. I'm going to subtract 12 on both sides to keep things equal. On the left side, those 12s cancel. I'm going to drop down my X, and then 23 minus 12 gives me 11 on the other side. So now, we defined our variable X as the number of miles from the friend's house to the beach, and we now got that X equals 11. It's not enough to stop here. We now need to actually say what X equals 11 represents. Okay, so we're just going to take our answer and turn it into a sentence. Okay, we can say that the friend lives 11 miles from the beach. Okay, so always make sure if the question is in words that you answer in words. I don't need a super complete sentence with amazing grammar, but I do need to know that you understood the context of the question and what you were solving for. All right, number 16, last one, then we're going to stop this video. It says, ballerina's name coming up here. Eastland's paycheck in July was 53 less than her paycheck in June. If Eastland's paycheck in June was $735.89, how much was Eastland's paycheck in July? So notice it says $53 less. Okay, so July was less than June. Okay, so what we're going to be doing is subtracting. Now notice I said it's often helpful to be able to sketch a diagram, but when we're talking about losing money, I mean, the diagram you would draw is you would draw out all the money and then scribble some of it out, right? That's not necessarily convenient when it's $735.89, right? You're not going to draw out $735 bills and 89 pennies. That'd be crazy. So instead, we're going to skip the diagram of this one. We're just going to go ahead and jump straight to the equation, but we are still going to define a variable. So what we are looking for, it says how much was Eastland's paycheck in July. So we are going to define that as our variable X. Okay, X is going to represent Eastland's paycheck in July. And so then we're going to write an equation that represents this. X is equal to, and it's $53 less than her paycheck in June. So I can phrase this as June's paycheck. And then $53 less than that means to subtract 53. Okay, but then I know what June's paycheck was. It's the 735 number. So we can then say that X is equal to 735.89 minus 53. Okay, we're going to have to do a little bit of subtraction here, which unfortunately is going to be, in my opinion, the less convenient kind of subtraction, where 35 is smaller than 53. So I'm going to write it over here on the side, 735.89. I'll put the 53 below it. Notice the decimals on the right just drop straight down. I don't have to actually subtract anything from them because it's 53.00 technically. All right, then 5 minus 3 is going to give me a 2. In order to do 3 minus 5, we're going to have to borrow 1 from the 7, so I'll change it to a 6. 13 minus 5 is 8. Drop down that 6. And we're going to get that Eastland's paycheck was $682.89 in July. And let me tell you guys, I know a little bit too much about this. That's actually not bad for a ballerina's paycheck in July. They tend to get the summers off. So having any money at all, actually a pretty big win for Eastland there. All right, now we need to make sure we answer in words because the question was in words. So we're just going to take this and say that Eastland's July paycheck was, and we'll put a dollar sign on it, $682.89. All right, we'll finish off the other part of the video about division and multiplication in a separate video. Thank you guys for tuning in, and see you in class.